Now we're going to learn how to solve simple equations. Now that's some very, very easy algebra. And we're going to learn it because it's a tool for what we're going to be doing in percents and also later on in geometry. And here's our very first equation. It says x plus 5 equals 12. And you say, Uncle Dan, what's x? X is just some number. You don't know what it is, but you'd like to find out what it is. Some number plus 5 equals 12. Most of you are probably able to just look at that and tell me the answer. What number plus 5 will give you 12?
7.
7. But what is important here is not just getting the answer, but how we get the answer, the process that we use to get the answer, and the very special way we write it down. We see that the relationship, the operation going on between the x and the 5 is adding. It's addition. It's plus. In order to solve the equation, we're going to use the opposite operation. What is the opposite of addition?
Subtraction.
So we're going to subtract 5 from each side of the equation. An equation means that what you have on one side is equal to or has the same value as what you have on the other side. And we're going to subtract 5 from each side. Whatever you do to the one side, you have to do to the other. Now let's look at the plus 5 and the minus 5. What happens when you put those two things together? What do you get?
0.
Let's take a moment to show why that's true. Here is what we call a number line. 0, 1, 2, 3, 4, 5. We started out and our first number was plus 5. That brings us out to here. And from there, we're going to have our minus 5. That sends us back here. And where did we wind up?
0.
We wound up at 0, and that shows us that plus 5 and minus 5 put together and become 0. So we don't really have them anymore. And all we have left there is x. And that's what we wanted. We wanted to get the x all by itself on one side so we could find out what it's equal to. Well, all we have to do on this side is say 12 minus 5 is
7.
7. So we say x equals 7. And as we write it down on the paper, we should try and have all of our equal signs in a nice straight line. Now we're going to do what we call the check. We'll put a little line under it, and we'll look at the original equation. The original equation is x plus 5 equals 12. And we're going to write that original equation again, except for one thing. Instead of the x, we're going to write what the answer was, what we found out that x is equal to. And we found out that x is equal to
7.
So we're going to substitute that number for x, or plug it in to our original equation and say 7 plus 5 equals 12. All I've done is write down the original, but instead of x, I write 7. Here's the plus 5, and it's supposed to equal 12. And here's how we find out if that's really true. You look at each side of the equation separately. You just look at these two numbers. What does 7 plus 5 equal?
12.
And what do we have already on this side of the equation?
12.
So, we have made both sides look exactly alike. It says 12 equals 12. And because we were able to work with one side and make it look exactly like the other, that shows us that we got the right answer. And we put a little check, and it's done. Let's do another one just like it. X plus 3 equals 7. What is the relationship? What operation is going on between the x and the 3?
Addition.
Addition. So I'm going to do the opposite, which is subtraction. And the number I want to subtract from each side is this number right here, because I want that 3 to disappear. And when I put the plus 3 and the minus 3 together, what do I get?
0.
And that leaves me with, on this side, just plain x. And 7 minus 3 is what?
4.
4. The answer is 4. Now we do the check. X, we found out, is 4. We put that in. 4. 4 plus the 3 is supposed to equal 7. Here's our original equation, and we've just substituted 4 for x. Well, what does 4 plus 3 equal?
7.
7 equals 7. Yes, we got it right. X minus 5 equals 12. This time, what is the operation, the relationship between the x and the 5?
Subtraction.
So we need to do the opposite, which is
Addition.
we're going to add 5 to each side. The minus 5 and the plus 5, when we put them together, become what?
0.
0, leaving us just x. And on this side, 12 plus 5 is
17.
17. And again, we do the check. We plug in the 17 into the original equation. X, which is now 17, minus 5 equals 12. 17 minus 5 is supposed to equal 12. Now we work on this side. What is 17 minus 5?
12.
12 equals 12. Both sides look alike, and we have gotten it right. And here's another one just like it. X minus 3 equals 7. Again, what operation is going on between the x and the 3?
Subtraction.
And we need to do the opposite, which is,
Addition.
and what number are we going to add to both sides of this equation?
3.
Plus 3 plus 3. The minus 3 and the plus 3 together become
0.
which leaves us just the x on this side. On the other side, 7 plus 3 is
10.
7 plus 3 is 10. X equals 10. And the check. Plugging in the 10 into the original equation. 10 minus 3 is supposed to equal 7. Well, what is 10 minus 3?
7.
7 equals 7. Yes, we got it right. The next one says 5x equals 10. What does that mean, 5x? What is the operation going on here between the 5 and the x? It means that we have 5 x's. We have that x 5 times. So the operation that's going on there is
Multiplication.
multiplication. And what is the opposite of multiplication?
Division.
Division. And the way we divide both sides of the equation is to draw a line under each number and put the 5 under each number. This line is like a fraction line, and it's like a division line. We can see that 5 divided by 5 is 1. 5 divided by 5 is 1. It's just like canceling a fraction. 5 into 5 is 1, 5 into 5 is 1. And what's 1 times x?
1.
Well, what's 1 times 8?
8.
What's 1 times 9?
9.
What's 1 times 3?
3.
What's 1 times x?
X.
1 times x is x, and x over 1 is x. All that to say that if you divide the 5x by 5, everything cancels out and leaves you just plain x. On this side, we have 10 divided by 5, which is
2.
It's just like an improper fraction, isn't it? And if you have an improper fraction, you divide the bottom into the top. 5 into 10 is
2.
Now we do the check. 5 times x is 10. Here's the 5, and the x is 2. And instead of using a little x like that for a times sign, since we don't want to confuse this x with this x, when we do an equation and when we do any algebra, our times sign is a little dot like this. And we don't put it down here on the line because then it would look like a decimal point. We put it right up here, half the height of the number. So it says now 5 times 2 is supposed to equal 10. Well, what does 5 times 2 equal?
10.
10 equals 10, and the check shows that we got it right. Three x equals 9. What is the operation going on between the 3 and the x?
Multiplication.
So what operation do we use to solve the equation?
Division.
We divide both sides by what number?
3.
3. These 3's cancel away and leave us on this side with just plain.
X.
And on this side, 9 divided by 3 is?
3.
Let's do the check. 3 times what we found out x is, 3 is supposed to equal 9. What is 3 times 3?
9.
9 equals 9. And yes, we got it right. X over 4 equals 8. That's the way we read it. We say x over 4, like it's a fraction. Now, what operation is going on between the x and the 4?
Division.
Yes, division. The fraction line, as we've said before, means division. Well, if the operation that's going on is division, we have to use the opposite. What is the opposite of division?
Multiplication.
We're going to multiply both sides of the equation by 4. Now, if you want, you could say that this is 4 over 1, but you don't really need to write that down. You can just realize that it's the top number, and these will cancel away, leaving you on this side just plain
X.
And on the other side, we have 8 times 4, which is what?
32.
32. Let's do the check. The original equation said x over 4, but x is equal to 32. 32 over 4 is supposed to equal 8. 8 was the original number in the equation. Well, what is 32 divided by 4?
8.
8 equals 8, and that shows us that we didn't make any mistakes along the way. And here's another one just like it. X over 5 equals 3. What is the relation between the x and the 5? What operation is happening there?
Division.
So we have to do the opposite, which is
Multiplication.
we will multiply both sides of the equation by
5.
5. These cancel away, one on the top, one on the bottom, and we get on this side just plain
X.
x equals 3 times 5, which is,
15.
and the check. X, we found out, is 15. 15 over 5 is supposed to equal 3. Well, what is 15 divided by 5?
3.
3 equals 3, and that shows that we got it right. So far, we've learned how to solve equations of 4 different kinds when the operation involved was addition, or subtraction, or multiplication, or division. But here's one more kind that's very, very important. 2/3 x equals 24. This time we have a fraction in front of the x. We would like to see that fraction disappear so that the x will be by itself. And we have a very special trick to make it disappear. We multiply both sides of this equation by what we call the flip-flop of 2/3. The flip-flop of 2/3 is 3/2. We just take it and turn it upside down. We do it to this side, and we also do it to this side. And we have a very tricky way of writing it. We just draw a line here and put the 2 underneath. There's the 3/2. Now, on this side, we can just cancel away the 3's and the 2's, and we'll end up with just plain.
X.
And on this side, we see that we can cancel the 2 and the 24. 2 into 2 is?
1.
And 2 into 24 is?
12.
And 12 times 3. Can you do that in your head? If not, we'll just say 2 times 3 is 6, and 1 times 3 is 3. 12 times 3 is 36. We find out that answer, but the place we write it is right here. X equals 36. You're going to be using this kind of equation many, many times in your work with percents. Now we're going to do the check. The original equation was 2/3 x equals 24. 2/3 times x, which we found out is 36, and we'll just put it over 1. And that's supposed to equal 24. Let's see if that's so. We can cancel the 3 and the 36. 3 into 3 is?
1.
And 3 into 36 is? 12. And 2 times 12 is? 24. 24 equals 24. Yes, we got it right, and we had to do quite a bit of work to find out. Let's do another one just like it. One-eighth of x is 48. Again, we have a fraction in front of the x. In order to make that fraction disappear, we have to multiply both sides by the flip-flop, which is 8 over 1. And this side, we'll just write the 8, because we know that 8 over 1 is really just plain 8. These cancel away, leaving us just plain
X.
And 48 times 8, well, we can't really do that in our heads. Let's multiply it out. 8 times 8 is?
64.
Put down the 4, carry the 6. 4 times 8 is?
32.
Plus 6,
38.
38. X equals 384. Let's see if we got it right. 1/8 times x, which we now know is 384, is supposed to equal our original number from the equation 48. Well, let's see if we can cancel 8 and 384. Let's do the division. 8 into 384. 8 into 38 is?
4.
4 times 8.
38.
8 take away 2.
6.
Bring down the 4. 8 into 64.
8.
8 times 8 is?
64.
64. 160. Excuse me. Up here we have our answer from the division, 48, and we see that 48 equals 48. Now, the reason that we've taken the time to learn these equations is to help you know how to lay them out on the paper and to get you used to working down one side and down the other side with your equal signs lined up in the center, because that's how we're going to do most of our problems with percents. In your booklet, there are several problems in the next section for you to practice on. you should try them on your own first, and then watch this next section of the video to see if you did them correctly. Here's 6 more equations just to make sure that you understand how to do them. The first one is x plus 9 equals 11. What operation is happening between the x and the 9?
Addition.
And we have to use the opposite operation, which is?
Subtraction.
We'll subtract 9 from both sides. The plus 9 and the minus 9 together become?
0.
Leaving us on this side just plain.
X.
On the other side, 11 minus 9 is?
2.
X equals 2. And the check. X, which we found out is 2, plus the 9 is equal to 11. 2 plus 9, what does it equal?
11.
Yes, 11 equals 11, and that shows that we got it right. X minus 5 equals 4. What is the operation happening between the x and the 5?
Subtraction.
And what is the opposite operation for that?
Addition.
So what number do we have to add to both sides of this equation?
5.
Plus 5 plus 5. The minus 5 and the plus 5 put together give you?
0.
Which leaves on this side just plain.
X.
On the other side, 4 plus 5 is?
9.
And the check. X is 9. 9 minus 5 is supposed to equal 4. What is 9 minus 5?
4.
4 equals 4, and we got it right. Four x equals 16. What operation is going on between the 4 and the x?
Multiplication.
And what is the opposite of multiplication?
Division.
We have to divide both sides of the equation by?
4.
4. These cancel away. On this side, we have just plain.
X.
On the other side, 16 divided by 4 is?
4.
And the check. 4 times x, which we know is 4, is supposed to equal 16. What is 4 times 4?
16.
And on the other side, we already have?
16.
16 equals 16. That shows we got it right. X over 5 equals 8. What is the operation between the x and the 5?
The division.
And what is the opposite of division?
Multiplication.
We're going to multiply both sides of the equation by?
5.
5. These cancel away, leaving us on this side
X.
x. On the other side, 8 times 5 is?
40.
And the check. X, which we found out is 40. 40 over 5 is supposed to equal 8. What is 40 divided by 5?
8.
8 equals 8, and we got it right. Three-fourths times x equals 24. This time we have a fraction in front of the x, and the way to get rid of that fraction is to multiply both sides by the
Flip-flop.
The flip-flop of 3/4 is 4/3. Here's the 4, and there's the 3. These cancel away. On this side, we have just plain,
X.
and on the other side, the 3 can cancel with the 24. 3 into 3 is?
1.
3 into 24 is?
8.
8 times 4 is?
32.
32. And the check. The original equation was 3/4 x equals 24. 3/4 times 32 is supposed to equal 24. Cancel the 4 and the 32. 4 into 4 is?
1.
4 into 32 is?
8.
3 times 8 is?
24.
Equals 24. And we got it right. And the last one of these that I'll do for you, 1/3 x equals 9. Again, we have a fraction in front of the x. We have to multiply both sides by the
Flip-flop.
The flip-flop of 1/3 is 3/1, which is the same thing as just plain 3. These cancel away. On this side, we are left with?
X.
On the other side, 9 times 3 is?
27.
And the check. 1/3 times x, which is 27, is supposed to equal 9. 3 into 3 is?
1.
3 into 27 is?
9.
9. 9 equals 9. So this practice in solving equations gets you accustomed to working down one side and working down the other side and bringing your numbers straight down and keeping them in the proper places. And you'll need to do just that in the very next part of the video called the 3 cases of percents. Are you ready?
Yes.
Okay, here we go. Now we're ready for the 3 cases of percent, or the 3 types of percent problems. The first type, type 1, is when you need to find the part of the whole. Here's our first one. 40% of 70 is what? We know the percent. How much is the percent?
40%.
And we know the whole thing. How much is it?
70.
40% of 70. 70 is the whole thing. But we don't know how much a smaller piece, just 40% of 70, is. That's what we want to find out. the part of the whole. And when we need to know the part of the whole, we'll call that type 1. This is what's called a number sentence. It has numbers and words. And we'll always start out with a number sentence, and then we'll change it to an equation, and then we'll solve it. The first thing we need to do is convert 40% to a fraction. 40% is the same thing as 40 hundredths, or 4 tenths. As a fraction, that's 4 tenths, and that can be reduced to what?
2/5.
2/5. Now, that's even one that you should know automatically. As soon as you see 40%, you should know 2/5. But I worked it out for you just as a review. We're going to bring this straight down, but change to 2/5. The next thing we see in our number sentence is the word of. And what does of always mean in mathematics?
Times.
Times. And our times sign is just going to be a dot. 2/5 of 70, and we'll put the 70 over 1. What shall we put for the word is?
Equals.
Equals. And what shall we put for this empty box, the number that we don't know?
X.
X. And there we have kind of an equation. It's not exactly like the equations you've done already, but you see that we're going to work down each side. On this side, we have a multiplication problem. Can we cancel anything?
Yes.
We can cancel the 5 and the 70. We can hit them both with what?
5.
5 into 5 is?
1.
And 5 into 70 will do on the side. 5 into 7 is?
1.
1 times 5.
5.
7 take away 5.
2.
Bring down the 0. 5 into 20.
4.
4 times 5
20.
comes out even. It goes in 14 times. Now we have to multiply across. 2 times 14 is what?
28.
It is 28. And we take the answer, and since we're working down this side, we just write the 28 here. 28 equals, and here we already have x. The answer is 28. And now we can take the 28 and put it in the box. Now let's see if that makes sense. The whole thing was 70, but we only want 40% of it, a piece of it, only 2/5 of it. Doesn't it make sense that a piece that was 2/5 of 70 would be about 28?
Yes.
Yes, I think it does. And it's always good to look at your answer and just step back and see if your answer makes sense, because if it doesn't, then there's something wrong. Here's the next one. 75% of 36 is what? 75% is a percent that you all know. What is it as a fraction in lowest terms?
3/4.
3/4. Of becomes
Times.
36 over 1. Is becomes,
Equals.
and the box becomes.
X.
Can we cancel?
Yes.
We can hit the 4 and the 36 with 4. 4 into 4 is?
1.
4 into 36 is?
9.
3 times 9 is?
27.
27 equals x. So we can put 27 in the box. Does it make sense that 75% or 3/4 of 36 would be about 27?
Yes.
Yes, it does. Remember, this was a type 1 problem. We knew the percent, we knew the whole thing, but we need to find a part of the whole. What is 25% of 48? Now this one might look a little bit different than the other ones, but it is the same kind of problem. I've just written it backwards. In the other one, the box was over here and this part was over there, each on a different side of the word is. But it's still the same type of problem because we know the percent, we know the whole thing, and we're looking for a part of the whole. In these kinds of problems, the number that comes after the word of is always the whole thing. We want to find out 25% of 48. 48 is the whole thing. Well, what does the box become?
X
And the is.
equals
And what is 25% as a fraction in lowest terms?
1/4
1/4. Of is,
times
and we'll put the 48 over 1. Can we cancel?
yes.
With what number should we hit both 4 and 48?
4
4 into 4 is,
1
and 4 into 48. 4 into 4,
1
4 into 8,
2
12. 1 times 12 is
12
x equals 12. 12 is 25% of 48. 12 is the part of the whole. %37.5% of 24 is what? And this time I've written it the same way as I did the other two so that the box is at the end. And that's the way we'll usually do it. Do you recognize 37.5%?
yes.
It's a memory percent, and it comes from what fraction?
3/8
3/8 times 24 over 1 equals x. Can we cancel?
yes.
Using what?
8
8 into 8 is?
1
8 into 24,
3
3 times 3,
9
9 equals x. And our answer is 9. %150 of 72 is what? Now here we have a percent that's more than 100%. 150%. We move the decimal point 2 places back, and we get 1.5, which is the same as 1 5/10, and the 5/10 reduces to what?
1/2.
But we still have a mixed number. We can change it to an improper fraction. 2 times 1 is?
2.
Plus 1 is?
3.
3/2. 150% is 3/2 times 72 over 1 equals x. Can we cancel?
Yes.
2 into 2 is?
1.
2 into 72. 2 into 7?
2.
3. 3 times 2?
6.
7 take away 6?
1.
Bring down the 2. 2 into 12?
6.
6 times 2 is 12. It came out even, and we got 36. Now we have to multiply 3 times 36. 36 times 3. 6 times 3?
18.
Carry the 1. 3 times 3?
9.
Plus 1?
10.
108. 108 equals x. 108. But Uncle Dan, 108 is even bigger than 72. That's because 150% is more than 100%. It's more than the whole thing. $26 of 33 is what? Well, 26%. Let's change it first to a decimal. Move the decimal point back 2 places to the
Left.
We have 0.26. Please read that number.
26 hundredths.
Can it be reduced?
Yes.
What shall we hit those numbers with?
2.
2 into 26 is? We'll do it down here. 2 into 2?
1.
2 into 6?
3.
13. And what is 2 into 100?
50.
50. 13 fiftieths. Well, we'll try that. We'll say 13 fiftieths times 33 over 1 is or equals x. Can we cancel?
No.
No, we cannot cancel. We especially cannot cancel so that we'll get a 1 on the bottom. That means we should not use the fraction. When you cannot get it to cancel so that you get a 1 on the bottom here, instead of the fraction, you should use the
Decimal.
So we'll erase this and use 0.26, and we no longer need to have the 33 over 1. But we do have a multiplication problem. 0.26 times 33. And we'll have to do that work on the side. 0.26 times 33. Six times 3?
18.
Carry the 1. 2 times 3
6,
plus 1.
7,
And the second row is also by 3. We put in our 0, and we'll get, again, 78. And now we add them up. 8 plus 0,
8,
7 plus 8,
15,
carry the 1. 1 plus 7,
8,
where should we put the decimal point? Well, how many places are there filled in this problem that are to the right of decimal points?
2,
Just these 2. So we go back 1, 2, and we get 8.58. 8.58 equals x. And that's our answer. As you can see, it didn't come out very evenly. But we expect that, because if it had come out evenly, we probably could have used the fraction way. But we couldn't use the fraction way in this problem because we couldn't get it to cancel. So when you have to use the decimal way, you can expect an answer something like that. So those are the type 1 problems, where you know the percent, you know the whole thing, and you need to find the part of the whole. Now we're going to do the type 2 problems, where the thing you don't know is the percent. We call these the what percent problems. Here's the first one. 20 is what percent of 50? We know the whole thing. That comes after the word of, and the whole thing is
50,
and we know the part of the whole. How much is the part of the whole?
20,
But we don't know what percent 20 is of the 50. And that's what we need to find out. Now, in type 2 problems, you do not have to set up an equation. You just have to realize that percents come from fractions, and we're going to make a fraction out of these 2 numbers. We always put the part on the top and the whole on the bottom. The bottom number is always the one that comes after this word of. Now, we can reduce this fraction just by hitting top and bottom with 10. And then we have 2/5. How much percent is 2/5?
40%,
That is 40%, and we can just put the 40 in the box. It's just as easy as that. 20 is 40% of 50. Here's the next one. 6 is what percent of 9? We make a fraction out of it because it's a type 2 problem. What percent? Which number do we put on the bottom, the 6 or the 9?
the 9,
The 9 is on the bottom because it comes after the word,
of,
and we put the 6 on the top. Can it be reduced?
yes,
What shall we use to reduce it?
3,
3 into 6 is,
2,
and 3 into 3 is
3,
2/3. Do you know how much percent 2/3 is?
yes,
Yes, how much?
66 and 2/3%.
66 and 2/3%. That's one of your memory percents, and we'll put the 66 and 2/3 right there in the box. 6 is 66 and 2/3% of 9. What percent of 16 is 4? Well, again, I've written this one backwards just to show you that it might be presented that way. But still, we know the whole thing. How much is the whole thing?
16.
And how much is the part?
4.
But it's what percent? We don't know the percent, and that makes it a type 2 problem. Well, we have to make a fraction. What number goes on the bottom?
16.
Because it came after the word,
Of.
and the top we have 4. Let's reduce that one. We can hit top and bottom with
4.
4 into 4,
1.
4 into 16.
4.
1/4 is equal to how much percent?
25%.
25%. 25% of 16 is 4. Four is what percent of 5? What percent? A type 2 problem. What number goes on the bottom of our fraction?
5.
And the 4 goes on top. 4/5 is equal to how much percent?
80%.
It's 80%. If you forgot, you can raise it up to 8/10, and you can even say 8/10 as a decimal, add a 0, move over 2 places, and you'll see that it's 80%. 80%. The next one, I'll just put them up there together. 5 is what percent of 4? We're going to make a fraction, and which number should we put on the bottom?
4.
Because it comes after the word,
Of.
so we have 4 on the bottom and 5 on the top. What kind of fraction is that?
An improper fraction.
Yes, that is a fraction that is not proper. Because the top number is not smaller than the bottom number. So, what shall we do with it? We have to divide the bottom into the top. We'll do that on the side. 4 goes into 5 how many times?
1.
1 times 4,
4.
with how much left over?
1.
1 what?
1/4.
1 and 1/4. Well, let's just use our shortcuts. How much percent is 1?
100.
How much percent is 1/4?
25%.
How much altogether?
125%.
125%. And that's more than 100% because 5 is greater than 4. The next section of the video will have problems of type 1 and type 2 mixed together. And it's your job to figure out which ones are type 1 and which ones are type 2, and then solve them. You should try the ones that are in the box first, and then watch the video and see how you did. So now, you know how to do problems that are type 1. You know how to do problems that are type 2. Let's see if you can tell them apart. The first one is 20% of 75 is what? Do you know the percent?
Yes.
Yes, you do. 20%. Do you know the whole thing?
Yes.
75. Do not know the part of the whole. Therefore, what type is it?
1.
Type 1. 20% is what as a fraction in lowest terms?
1/5.
1/5 of becomes times 75 over 1 equals x. Can we cancel?
Yes.
5 into 5 is
1.
5 into 75. 5 into 7,
1.
1 times 5,
5.
7, take away 5.
2.
Bring down the 5. 5 into 25.
5.
5 times 5,
25.
the answer is 15. And 1 times 15 is 15. 15 equals x. 15. A type 1 problem, the part of the whole. Three is what percent of 8? Do you know the percent?
No.
You don't know the percent. It's a what percent problem. Therefore, it is type
2.
So we make a fraction. Which number do we put on the bottom of our fraction?
8.
8, because it comes after the word,
Of.
and we have 3/8. How much percent is that?
37.5%.
37.5%. That's a memory percent. %75 of 25 is what? Do we know the percent?
Yes.
Do we know the whole thing?
Yes.
25. Do we know the part of the whole?
No.
So therefore, it's type.
1.
Well, let's look at this percent. 175%. We can move the decimal point back 2 places and get 1.75. Read that to me.
1.75.
1.75. And what does 75 reduce to?
3/4.
You should recognize that that's 3/4. 1 3/4. Well, we could change that to an improper fraction. 4 times 1
4.
plus 3,
7.
7/4. Now we have to decide whether to use the fraction or the decimal. The fraction is 7/4. If we use 7/4, can we cancel the 4 and the 25?
No.
No, we can't. We're going to have to use the decimal. The decimal is 1.75 times 25 equals x. Generally, when you have to use the decimal, you'll find out that you have more work to do and you'll have an answer that's a little bit unusual. So, if we have a choice, we'll always use the fraction. But if we don't have a choice, if the fraction won't cancel, then we'll use the decimal. Well, we have to multiply 1.75 times 25. 5 times 5.
25.
Put down the 5, carry the 2. 7 times 5
35.
plus 2,
37.
37. Put down the 7, carry the 3. 1 times 5
5.
plus 3,
8.
8. A 0 to start the second row. 5 times 2,
10.
put down the 0, carry the 1. 7 times 2
14.
plus 1,
15.
put down the 5, carry the 1. 1 times 2
2.
plus 1,
3.
3. Let's add them up. 5 plus 0,
5.
7 plus 0,
7.
8 plus 5,
13.
carry the 1. 1 plus 3,
4.
4. In the problem, how many places to the right of a decimal point are filled?
2.
2. So we go back 2 places and put in our decimal point. Our answer is 43.75 equals x. And we can write that in the box. Please read that number.
43 75/100.
Now let's see if our answer makes sense. And that's especially a good idea to do if you had to use a decimal, because you want to make sure that your decimal point is truly in the right place. It says 175% of 25. 175% is more than 100%. So we have to have an answer that's more than this number, 25. Almost twice as much. If this were 200%, that would be twice as much. Well, we got an answer of 43. Is that more than 25?
Yes.
Is it almost twice as much?
Yes.
So that shows that our answer is in the right ballpark. It's approximately okay. If we had put the decimal point in the wrong place, we might have an answer like that. That would be too small. And if we put the answer like this, we'd have an answer that was way too large. So it's always good to see if your answer looks all right. What is 80% of 65? Do we know the percent?
Yes.
Do we know the whole thing?
Yes.
Do we know the part of the whole?
No.
So therefore it's type
1.
type 1. This time I've written it backwards just to make it a little more difficult to see what kind of problem it was, but you could see it's type 1. The box becomes X, the is becomes equals. What is 80%? 80% as a fraction.
4/5.
4/5 times 65 over 1. Do you think we can cancel the 5 with the 65?
Yes.
Yes, we can, using 5. 5 into 5 is?
1.
And 5 into 65. 5 into 6?
1.
1 times 5?
5.
6 take away 5?
1.
Bring down the 5. 5 into 15.
3.
3 times 5?
15.
And we get 13. Now we have to multiply 4 times 13. 13 times 4. 3 times 4?
12.
Carry the 1. 1 times 4
4.
plus 1.
5.
X equals 52. The answer is 52. And it makes sense. 80% is a rather large piece of 65, and 52 is a rather large piece of 65. And here's the last one. What percent of 6 is 9? Do we know the percent?
No.
So therefore, this one is type,
2.
and I've written this one backwards compared to the way we usually do it, but you can see right away that it's type 2. We have to make a fraction. Which number should I make as the bottom number?
6.
6, because it comes after the word,
Oh.
so the top number is 9. And that is an improper fraction. We have to divide the 6 into the 9. 6 into 9,
1.
1 times 6,
6.
subtract, get
3.
3 what?
3, 6.
3 6. 1 and 3 6. And the 3 6 can be reduced to what?
1/2.
1/2 by using 3. 3 into 3 is 1. 3 into 6 is 2. Now, how much percent is 1?
100.
And how much percent is 1/2?
50.
Putting those together, we get how much percent?
150%.
150% of 6 is 9. 150% is more than 100%. It'll be more than 6. 150% of 6 is 9. Now we're ready for the type 3 problem. The kind of problem when you don't know the number that comes after the word of. So I like to call it the of what problem, when you don't know how much is the whole thing. Here's the first one. 18 is 75% of what? Do you know the percent?
Yes.
Do you know the part of the whole?
Yes.
Do you know the whole thing?
No.
No, you don't. You don't know the number that comes after the word of. Just like in type 1, we're going to bring everything down from the number sentence and make it into an equation. 18 equals, what is 75% as a fraction in lowest terms?
3/4.
3/4. And what is the box?
X.
X. And we can just say 3/4 X. And we don't even need to say times, because 3/4 X means times. Now, we have an equation with a fraction in front of the X, and we would like that fraction to disappear. In order to do that, we have to multiply both sides of the equation by the
Flip-flop.
flip-flop. 4/3. 4/3. These cancel out, leaving us on this side of the equation just plain
X.
X. Here we can cancel the 3 and the 18. 3 into 3 is
1.
3 into 18.
6.
4 times 6 is,
24.
and our answer is 24. 18 is 75% of 24. And that makes sense because 18 is a fairly large chunk of 24, and 75% is a fairly large chunk. $25 is 83 1/3% of what? 25 equals, from what fraction do we get 83 1/3%?
5/6.
5/6 is one of your memory percents of X. Again, we have a fraction in front of the X. We multiply both sides by the
Flip-flop.
6/5. 6/5. These cancel away, leaving us what on this side of the equation?
X.
X. Here we can cancel the 5 and the 25. 5 into 5 is?
1.
5 into 25?
5.
And 6 times 5 is?
30.
30. 30 equals X. 30. 25 is 83 1/3% of 30. %% of what is 21? I've written this one down a little bit differently, but you can still see that it's an of what problem. Do we know the percent?
Yes.
Do we know the part of the whole?
Yes.
But we don't know the whole thing. Therefore, this is type number 3. 10%. What is 10% as a fraction in lowest terms?
1/10.
1/10 x equals 21. Since we have a fraction in front of the x, we have to multiply both sides by the
Flip-flop.
which is 10 over 1. And on this side, we'll just put 10. These cancel out, leaving us on this side just plain.
X.
And what is 21 times 10?
210.
Of course, you just have to add a 0 on the end of the 21 because you're multiplying by 10. 210. 10% of 210 is 21. $960 is 80% of what? 960 equals, what is 80% as a fraction in lowest terms?
4/5.
4/5 x. Again, we multiply both sides by the
Flip-flop.
5/4. 5/4. These cancel away, and on this side we have just plain.
X.
Over here, can we cancel the 4 and the 960?
Yes.
Let's find out for sure. 4 into 9.
2.
2 times 4.
8.
Subtract, get.
1.
Bring down the 6. 4 into 16.
4.
4 times 4.
16.
It's come out even, so we have the 0 there. 240. 4 into 4 is?
1.
4 into 960.
240.
Now we have to do 240 times 5. 240 times 5. 0 times 5.
0.
4 times 5.
20.
Carry the 2. 2 times 5
10.
plus 2.
12.
1200. 1200 equals x. 1200 is the answer, and it makes sense that 960 is 80% of 1200. $48 is 120% of what? 48 equals 120% is more than 100%. Let's see how to change it into a decimal and a fraction. First, we'll go back 2 places and take off the percent sign, and we get 1.2. Please read that to me.
1 2/10.
Which can be written 1 2/10. And the 2/10 can be reduced to
1 1/5.
1 1/5. The 2/10 reduces to 1/5. Now we can change that mixed number into an improper fraction. 5 times 1 is?
5.
Plus 1 is?
6.
6 fifths. 120% is the same thing as 6 fifths. 48 is 6 fifths of x. Now we need to multiply both sides by the
Flip-flop.
which is 5 sixths. 5 sixths. These cancel away, leaving us on this side just plain old
X.
over here. 6 into 6 is
1.
6 into 48.
8.
5 times 8,
40.
40. 40 equals x. 40. And it makes sense that 48 is 120% of 40 because 120% is more than 40 and 48 is more than 40. 120% is more than 100% is what I meant to say. Now you've learned how to do type 1, type 2, and type 3. In the next section, you'll find that those 3 types of problems are all mixed up together. You should try to do the ones in the box first on your own and then watch the video to see if you did them correctly. Now you know how to do types 1, 2, and 3. Let's see if you can tell them apart when they're all mixed up together. Here's the first one. 5 is what percent of 6? What type of problem is that?
2.
Type 2. Because it's a what percent problem. On type 2 problems, we have to make a fraction. Which number should I put on the bottom of my fraction?
6.
Because it comes after the word of. So we have 5 sixths, and what does that equal as a percent?
83 and 1/3%.
83 and 1/3%, which is one of your memory percents. %% of 75 is what? What type of problem is that one? Type number
1.
Type number 1. You know the percent, you know the whole thing, you're looking for a part of the whole. What is 20% as a fraction in lowest terms?
1/5.
1/5 times 75 over 1 equals x. Can I cancel the 5 with the 75?
Yes.
5 into 5 is
1.
5 into 75. You will see that it comes out to be 15. 1 times 15 is
15.
which equals x. The answer is 15. 20% of 75 is 15. 12 is 75% of what? Which type of problem is that? Type number
3.
Type number 3, because it is an of what problem, and you need to find out how much is the whole thing. 12 equals 75% is what as a fraction in lowest terms?
3/4.
3/4 x. Since we have a fraction in front of the x, we need to multiply both sides by the
Flip-flop.
4/3. 4/3. These cancel away, and on this side we have just plain
X.
3 into 3 is
1.
3 into 12 is
4.
4 times 4 is
16.
16 equals x. 12 is 75% of 16. What is 37.5% of 64? Which type is this one?
1.
Type 1. We know the percent. We know the whole thing. We need to find the part of the whole. I wrote it backwards just to see if I could trick you. X equals, from what fraction do we get 37.5%?
3/8.
3/8, one of your memory percents. 3/8 times 64/1. 8 into 8 is
1.
8 into 64.
8.
3 times 8,
24.
24 equals x. 24 is 37.5% of 64. Forty-3% of 119 is what? What type of problem is that?
1.
Type 1. We know the percent. We know the whole thing. We're looking for the part of the whole. 43%. That's not a percent that we recognize. Let's make it into a decimal by moving the decimal place 2 points to the left. We get 0.43. Read me that number.
43 hundredths.
Can that fraction be reduced?
No.
If we use that fraction, can we cancel the 100 with the 119?
No.
So we're going to have to use the decimal. 0.43 times 119 equals x. And now we have to do that long multiplication. 9 times 3.
27.
Put down the 7, carry the 2. 1 times 3
3.
plus 2.
5.
1 times 3.
3.
9 times 4.
36.
Put down the 6, carry the 3. 1 times 4.
4.
Plus 3,
7.
and 1 times 4.
4.
7 plus 0.
7.
5 plus 6.
11.
Carry the 1. 1 plus 3
4.
plus 7.
11.
Carry the 1. 1 plus 4.
5.
We have 2 places to the right of the decimal point filled. We go back 2 places and we get 51.17. 51.17 equals X. 51.17. And it makes sense that 43% of 119 should be about 50. Forty is 125% of what? What type of problem is that?
3.
That is a type 3 problem, and of what problem when you don't know how much is the whole thing. 40 equals 125%. Move the decimal point back 2 places and you get 1.25. Read that number.
1/2500ths.
Which reduces to 1 and
1/4.
perhaps you could see just by looking at 125% that the 100% comes from
1.
and the 25%,
1/4.
and then you could get the 1 and 1/4 right away. Let's change that to an improper fraction. 4 times 1 is
4.
plus 1,
5.
5/4. 40 equals 5/4 X. We have to multiply both sides by the
Flip-flop.
4/5. 4/5. These cancel away, leaving us just plain
X.
5 into 5 is
5.
1. 5 into 40 is
8.
4 times 8,
32.
32. 32 equals X. And it makes sense that 40 is 125% of 32 because 125% is more than 100% and 40 is more than 32. After you do the rest of the practice problems in your workbook, then you should take the test on pages 26 and 27. Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and Cracker Jacks. I don't care, oh, how there. I was just reminiscing about them good old days when Uncle Dan used to really pitch 'em. Now, sometimes he'd pitch his straight on, straight forward fastball. And sometimes he'd give him his slippery, dippery curveball. And they never knew which one was a-coming. It's kind of like it is with these percentage story problems, don't you know? Sometimes they're straight on and straightforward, and sometimes they got a curve in them, so watch out. And sometimes they contain the hidden question. Are you ready for percent word problems?
Yes.
Here's the first one. You were taking a test. There were 20 questions on the test, and 75% was your score. How many right? Our job is to read the problem and make a number sentence so that we can make that into an equation and find the solution. Do we know how much percent?
Yes.
Do we know the whole thing?
Yes.
So we need to find a part of the whole. We need to know how many of the whole were right. If we're looking for part of the whole, then it is type
1.
Type 1. And our number sentence will be 75% of 20 is what? What is 75% as a fraction in lowest terms?
3/4.
3/4 times 20 over 1 equals x. Can we cancel?
Yes.
We can cancel with 4. 4 into 4 is
1.
4 into 20.
5.
3 times 5.
15.
15 equals x. 15 is the answer. It tells how many questions we got right. 75% was how many questions were right. 75% of 20 is 15. Well, that first one was kind of straightforward, don't you think?
Yes.
Well, let's see about this one. 20 questions on the test. 85% was your score. How many wrong? 85% tells how many were right, but I'm asking how many are wrong. This time I'm throwing you a little bit of a curveball. Let's make up our number sentence. Do we know the percent?
Yes.
Do we know the whole thing?
Yes.
So we're looking for the part of the whole, and that means it's type number?
1.
Type number 1. There are 2 ways we can do it. 85% of 20 is what? What is 85% as a decimal in lowest terms? Well, that requires a little bit of work. 85%, moving the decimal point back 2 places, is 0.85. Read that number.
85 hundredths.
85 hundredths. Can we reduce it?
Yes.
Hitting top and bottom with
5.
5 into 100 is,
20.
and 5 into 85 is 17. 17 twentieths. 17 twentieths times 20 over 1 equals x. We can cancel out the 20s and we get 17 equals x. But 17 is the number that we got right. And we're being asked how many wrong. We know it's the number we got right because your score, the percent, is about how many you got right. So this is 17 right. So, because we have a curveball, we have one more step. We have to say that on the test there were 20 questions in all, and 17 were right. What do we do with those two numbers to find out how many were wrong?
Subtract.
And 20 take away 17 is 3. 3 were wrong. Here the answer was 17, but the real answer to the question was 3. 3 wrong because we had a curveball, and we'll call that type 1 curveball. But I said there's another way to do that one, because when you have a curveball, you have a choice as to whether to handle the curveball at the beginning of the problem or at the end. When we did it here, we took care of the curveball at the end. We found out how many were right and then subtracted to find out how many were wrong. Suppose we want to take care of that curveball first. If we got everything right on the test, we would have gotten 100% right. But our score was only 85%. What percent was how many we got wrong? What do I do with these two numbers to find out?
Subtract.
We subtract, and we get 15%. 100% would be everything right. 85% were right, so 15% were wrong. Then we can use that number. 15% of 20 is what? 15% is 15 hundredths. Can we reduce it?
Yes.
We hit top and bottom with 5. 5 into 15 is?
3.
And 5 into 100?
20.
3 twentieths. 3 twentieths times 20 over 1 equals x. The 20s cancel, leaving us 3. 3 equals x. And this time it's the number wrong because we use the percent that told how many were wrong. Our answer is 3, just like our answer was 3 when we did it the other way. So when you have a type 1 problem with a curveball, you have a choice. You can take care of that curveball at the very end of the problem, or you can take care of it at the beginning. "20 questions on the test. 16 were right. What was your percent score?" Do you know the percent?
No.
That means that this is a type
2.
Type 2. 16 is what percent of 20? Type 2 problems, we just need to make a fraction. Which number do we put on the bottom?
20.
20, because it is the whole thing and comes after the word of. The top number is
16.
Can we reduce it so that we can get a 10 on the bottom?
Yes.
What should we hit it with?
4.
Well, if we hit it with 4, we'll get a 5 on the bottom. But what should we hit it with if we would like to get a 10?
2.
2. That will save us a step. 2 into 16 is?
8.
2 into 20?
10.
And 8/10 is how much percent?
80%.
80%. Was this one straightforward or was it a curveball?
Straightforward.
Straightforward. It's just plain type 2. We'll put the type up there, and for our answer, we'll put 80%. "20 questions on the test. 2 wrong. What was your percent score?" Do we know the percent?
No.
That tells us it has to be type
2.
type 2. Let's try it. 2 is what percent of 20? 2. Since it's type 2, we just need to make a fraction. What number should we put on the bottom?
20.
And the 2 goes on the top. Can we reduce it?
Yes.
We hit them both with 2. 2 into 2 is?
1.
2 into 20?
10.
10. 1/10. How much percent is 1/10?
10%.
10%. Does that sound like we did very well on our test if we only got 10%?
No.
20 questions, 2 wrong, we must have done better than 10%. The reason is we have a curveball. Our percentage score that we want to know is about how many we got right, but we were told how many we got wrong. If we got 10% wrong, we can figure out how many we got right, what percent. If we had gotten them all right, we would have gotten 100%. But we got 10% wrong. What do I do with those two numbers?
Subtract.
And 100 take away 10 is?
90%.
90% right. That is your score. The answer goes here, 90%. And this time we handled the curveball at the end. But suppose we saw right away that there was a curveball and we wanted to take care of it first. Type 2 curveball. There were 20 questions on the test. 2 of them were wrong. What do I do with those 2 numbers to find out how many were right?
Subtract.
And we get 20 take away 2, 18 were right. Then we can say 18 is what percent of 20? We make a fraction with 20 on the bottom and 18 on the top. And what number can we use to reduce it?
2.
2 into 18 is?
9.
And 2 into 20?
10.
9/10. How much percent is that?
90%.
90%. And you see, we got the same answer as we got when we did it the other way. You don't have to do it both ways. You can choose either one way or the other way. Just remember that just like with type 1 curveball problems, with type 2 curveball problems, you have a choice. You can take care of the curveball at the very end of the problem or at the beginning. $65 was your score. 13 questions were right. How many questions were there on the test? Do you know the percent?
Yes.
Do you know the whole thing?
No.
Therefore, it is type number
3.
type 3. 13 is 65% of what? 13 equals, we have to find what 65% is as a fraction. We go back 2 places and take away the percent sign and get 0.65. Read that number.
6,500.
Can we reduce it?
Yes.
We can reduce it by using what number?
5.
5 into 100 is,
20.
and 5 into 65 will give us 13. 13/20. 13 is 13/20 x. Since we have a fraction in front of the x, we have to multiply both sides by the
Flip-flop.
20 over 13 and 20 over 13. This all cancels away, leaving us on this side just plain.
X.
And over here, the 13s cancel away and leave us 20. 20 questions on the test. 13 is 65% of 20. And that is our answer. That was a straightforward type 3 problem where you needed to find out the whole thing. $95 was your score. 1 question was wrong. How many questions on the test? Do you know the percent?
Yes.
Do you know the whole thing?
No.
You need to find out the whole thing. That tells you that it's type 3. But by now you might also be catching on that since I told you the number that was wrong, it's not only type 3, but it also has a
Curveball.
curveball. Type 3 curveball. And on type 3 curveball problems, you have to take care of the curveball first. And here's how. If you get everything right, you would get 100% on the test. But you got 95% right. What percent did you get wrong? What do we do with those 2 numbers?
Subtract.
100% take away 95% is,
5%.
and that's the number wrong. Then you can say 1 is 5% of what? 1 equals 5%, moving back 2 places, gives us the decimal 0.05. Read that number.
500.
500ths. Can that be reduced?
Yes.
By hitting them with 5. 5 into 5 is?
1.
And 5 into 100?
20.
1/20th. 1 is 1/20th x. We have to multiply both sides of the equation by the
Flip-flop.
20 over 1. And on this side, we'll just say 20. These cancel out, leaving us just plain,
X.
and 20 times 1 is,
20.
and the answer is therefore 20. There were 20 questions on the test. So anytime you have a type 3 curveball problem, you have to handle that curveball first. Now, you should try the next 6 practice problems in your book on your own, numbers 6 through 12, and then watch the video to see if you have done them correctly. And those 6 problems are all mixed up. There's 3 types, and some of them have curveballs, and some of them are straightforward. Let's see how you can do.
Golden Age Productions, Golden Age Productions, standing in the gap of your educational needs.